And so this technique can be applied to any to any grounded conductor, grounded conducting plane. So for example, if I had a setup where I had like a +2Q right here. Oh, sorry. +2Q here. Maybe I have just a negative Q right here, right? Maybe I have a +Q right here. And I have all these charges, and all of those charges are hanging out near an infinitely grounded conductor, right? Well, then instead, rather than dealing with this infinite grounded conductor, I can just replace this with a completely different problem where I have still the same +2Q. I still have the -Q over here, and maybe I have the +Q over here. And now I'm just going to put a dotted line here to indicate where the grounded charge was. And now I have -2Q on this side. Sorry, these are not at all nice circles, but hopefully you get the idea. Right? And all that matters here is that these distances are the same on both sides. So the distances have to be sort of equal and opposite, and the charges have to flip sign, right? So if you were to get a problem where you have a whole bunch of assortment of charges, you can swap that out for an equivalent problem where I have that same assortment of charges and I have these sort of image charges that are on the other side. And so we sort of label these are the real charges, and these are the image charges. Okay. However, two important things here. Two important notes about this sort of technique that we've discovered here. The first is that the solution is only valid in the region with the real charges. Meaning, let's look back at the example we just did. My substitute problem, the different problem I dealt with, the answer I have, I could in theory plug in values where z is negative, right? I could plug in values that look at the below the xy plane, right? I could plug them in there mathematically, but that is not valid for this problem. I could not take this equation and plug in negative values of z and assume that I'm going to get the same answer as I would for this previous problem. So it only works in the region where the real charges were in the first place. That's important. And then the second thing is that whenever we're doing this technique, we can never, if we run into a situation where we need to put image charges in different places, we can never place an image charge in the same region as an actual charge, as a real charge. Right? If I had some sort of weird situation where I had a couple different grounding planes, which we certainly could have, we could definitely have that situation. Then we would, I can't have it a way where, you know, I reflect and I get one image charge and then somehow it reflects again and gives me a charge right back where I started from on the first place. So I couldn't have that kind of thing. I can't have an image charge sort of up here. So no image charges on the top, and the solution is not valid down here, right? In the place where the image charges are. So those are kind of the two limitations of this. But once we know what we can do, that will sort of save us from having to do all this complicated integration that might come along with having to deal with this infinite grounded plane up here.